Welcome back everybody to linuxacademy.com. My name is Terry, and in today's course we continue our preparation for the Linux Foundation Certified System Administration exam. Specifically, we're going to continue our series of videos on routing traffic statically and dynamically. In our previous video, we showed how to route traffic to private networks using other gateways other than our default by inserting static routes using either the route add command or the IP route add command. The legacy command, of course, being the route add, and then the newer method for most distributions is IP route. Now, when we talk about dynamic routing, which is what we're going to be talking about here, there's a number of different tools and utilities that basically can turn your Linux system more or less into an intelligent router. And that's what we're talking about for dynamic routing. It's the ability to configure things so that it learns the most efficient routes for routing traffic. We obviously can't cover every single tool and utility that's around, so we're going to pick one. The previous standard used to be a utility that was called Zebra, and Zebra has been forked because the development ceased on Zebra some time ago. The authors ceased development on it, and it wasn't picked up by anyone else. So there is a fork called Quagga or Quagga. It's available in all Linux distributions. And if we're using, for example, our Ubuntu 14.04 system, all we would have to do is a sudo apt-get install on Quagga. It's already installed on this system, but just so that you're aware that over on a CentOS or Red Hat system, the Quagga utility is also available and the configuration is exactly the same. We're going to only have one of these systems set up as a router, so we're going to pick our our Linux Ubuntu system since it already has it installed. Once that's installed, we're going to use the CentOS system as the client, and then this Ubuntu system as the server or our router for dynamic routing. So the first thing that we need to do is we need to go into let's go ahead and become root. Sudo su. And we need to edit a couple of files. So let's do a cd etc and then Quagga. And in here we see a debian.conf and a daemons file. So we need to edit the daemons file, basically telling it that we want it to go ahead and configure itself so that Zebra and ript are being added. So in this case, let's do a Zebra equals 1 and ript equals 1. Now this is the old Zebra configuration for 1, and it looks like they may have changed the configuration to on and off. So we'll make sure, or yes and no. So we'll make sure that when we restart this particular service, that that we have the correct syntax in here. But let's go ahead and save this right now. Now we need to create a couple of files, and we need to create a zebra.conf and a ript or ripd.conf. So let's vim on zebra.conf, and then all we're going to do is put in here service Quagga restart hostname, which we need to get is OSX Ubuntu 14. So let's go ahead and copy that. And we'll add that to the end here. Paste. And then the password we'll just list as Quagga. And all we're going to do here is add this to both of these configuration files. So if we cat zebra.conf, we'll go ahead and copy this content, and then we'll vim vim on ripd.conf, And then we'll go ahead and insert this content here. And then from here, all we need to do is restart the Quagga service. So in this case, because we're on a sysvianet system, we're simply going to do a service Quagga restart. And we should see our Quagga process starting at that point. Now, we have our dynamic routing started at this point. And what we're really looking for is that the RIPD configuration is the configuration for the routing information protocol. So, and when we're talking about the router, we're referring to our Ubuntu system as the router in this case, exactly what we're working with here. And it provides our router, our Linux system, with information on what networks can be reached and how far in the terms of the hops that they are. Now, keep in mind, this is only one of the protocols that can be used with Quagga, and it's easy to configure and use, and most network devices support it. So from an example perspective, that's why we're using it. But we do need to make sure that we assign proper permissions to the configuration file. So let's go ahead and make sure that although we were able to start the scripts, we may have some permissions problems if we don't set the configurations to be owned by Quagga, and then this Quagga VTY, which we're going to be using for connection ownership. So if we do a chmod change mod or change mode, we're going to Quagga and Quagga VTY on the star.conf files. Change ownership rather, sorry. Quagga VTY star.conf, and then we're going to change mod and make sure that they're 640 so that we have the permissions correct on the configuration files. So now that we've got that, then what we want to do is go ahead and set up our service by doing a service Quagga and restart. And this will reread those configuration files with the proper permissions so that we don't have any issues when we load the routing modules. So at that point, we have these control mechanisms set up for Zebra and RIPD that we have to connect to and do some stuff with. So the first thing that we need to do is we're going to need to use a telnet. So make sure telnet's installed on our system, which it is. So we're going to do a telnet on localhost, and port 2601 should be listening, which is the port for Zebra. And it should tell us what's that user access verification, and it should be the password that we put in the configuration file, which it is. So what we need to do, once we've put in the password, we need to do enable. And again, if you've ever used Cisco's iOS, this is very similar to what you're going to see from within a router. We're actually treating our Linux system as a router. So let's configure our terminal. And now we're going to enter the IP address and network mask of our network interface card. So let's go back over here to a new tab. Make sure that we know we have the Ethernet 0 is 1.243. So what we need to do is we need to say enter ETH0 and then IP address of 192.168.1.243/24, rather, sorry. And then we have to make sure that we set up any other, so if we had multiple internet addresses here, we would simply create them. So we would do enter ETH0 and then IP address of the IP, etc., etc. So now we're going to exit, and then we have to write so that it saves the configuration to our Zebra configuration file, which will appear significantly different to us at this point in time. So let's go ahead and quit out of here and quit out of here, and we've now closed that configuration. Now we need to configure in a similar manner to the RIP daemon that's on port 2602. So let's go ahead and clear that, and we're just going to do telnet localhost 2602. And in the same method that we have a password set up for our Zebra configuration, we've got the same password because that's what we set up for our configuration here. So we need to enable, then we'll configure the terminal. We're going to do router RIP. We need to tell it version 2. We want to use the version 2 of the RIP protocol. Then we say network 192.168.1.0/24. And then we want to say, if we had a secondary network, we would say network 172 dot whatever /24, and then that way we would finish configuring the router. So if we hit exit in this case, because we only have one Ethernet card on this particular quote-unquote router that we're going to be using, we do an exit, and then we'll do a write, and we'll do an exit, and then we'll do an exit. Now if we look at those configuration files, cat rip d.configuration, we see we've got some changes here where it added the network information in here regarding the configuration that we added. So finally, IP route show rather, and we can see that our default protocol looks the same from a network perspective, but we've learned the routes that we dynamically can use for adding. So for example, if we ping google.com, we'll see that even though the Quagga process is now running for our system, we can use now this IP address becomes the dynamic router for all internet traffic. So for example, if I go over here to our quote-unquote client, now again we have on our server machine, we need to know our IP address for our server 192.168.1.243, and now we need to set up, so we need to do an IP route add default, and then 192.168.1.243 via 192.168.1.243. So we do an IP route show, which shows that we've changed our default route to 1.243. And now if we ping 192.168.1.1, which was our old gateway, we're still getting a response, and we get a response on 243 as well. So now we're using this particular server as the routing protocol for everything that we have on our system. So if we did an NS lookup, if we did a ping to Google, this is actually functioning as a router on our system so that we can dynamically assign routes from within here, and we could do multiple servers set up as multiple routers, and then we could have multiple interfaces that are either trunked together or responsible for multiple networks, and then we configure those IPs to route between them from a static routing perspective, a way of segmenting our network. Again, keep in mind that this isn't intended to be a comprehensive dynamic routing tutorial. This is just explaining what dynamic routing is, how it works from within Linux, and how you can configure a Linux server to use dynamic routing to learn routing protocols appropriately. It's kind of a jumping off point for you, but there are a number of different ways you can use it, including in conjunction with your IP tables. So for the basics of setting up Linux for dynamic routing, for routing traffic from within our network, that's all there is to it. My name is Terry for Linux Academy.